Good morning, and thank you to come here this morning. Today, I'm going to introduce you the Intel Deep Learning SDK. I'm Michele Tameni. I'm a free software engineer, and I am part of the Intel Software Innovator program. This program is meant to bring engineer to show off the Intel technology and innovation. And as I told you, I'm a software engineer, I'm a writer, I'm a photographer, but there's something that I'm sorry not, and I'm not a data scientist. And I think this is quite important to tell you, because first, I can avoid your tricky mathematical question on the deep learning field. And second, because all the point of this SDK is to lowering the barrier to get started in deep learning. So the Intel Deep Learning SDK is an easy solution to develop, deploy deep learning solution, optimized for the Intel architecture. It is using all the popular frameworks that already we have, like TensorFlow, and Caffe, and many others. So the problem with deep learning today is that it's not really accessible. There is so many tools, so many choices to do, and for someone that want to get started, it's quite complicated to get even installed all these tools. And the idea is to try to give a tool to just install all the needed stuff, better if it can be optimized for the architecture without the need to buy anything new, not new hardware, no new software license, but just still use what you already have. So deep learning, actually, it's pretty much everywhere. It's the future of technology, but it's even the present. And it's really good to solve a visual understanding problem, so to get idea of what there is in an image. And also, it's used for text analyzing, classification, translation, and for voice recognition. So every voice assistant that you are using today probably use deep learning under the hood. And also, autonomous car, it's a quite important field, actually. It's using deep learning a lot. And maybe you know that Intel is famous for its hardware, but it's one of the biggest software house, actually, and it's using deep learning everywhere. From product design to improve the design of the processor, for the manufacturing to improve time and build quality, to give recommendation to the sales marketing, for the perceptual computing, so visual recognition, VR headset, and RealSense SDK, and even on IoT products. It's also started a health analysis program to try to find a solution to some disease. But I'm not going to explain how deep learning works today, because it's quite complicated field. I just want to introduce some of the concepts that you need to get started with the SDK, and just to have some common terminology here. So deep learning is inspired by how the human brain works, and it consists of a multi-layered network of neurons. And these neurons, usually you give these neurons an input, it do some processing, pass to the other layers, and at the end you get the probability of the input being something. So like a person in the image, or a cat, or a dog, or a car, or something like that. This network, it's called a topology. And the topology may differ from the number of layers, the number of the essence of the neurons. And there is some really good topology that is good to solve some specific problem. And the process of the deep learning can be divided into big parts, the training part and the inference part. In the training part, you need to prepare a large data set of image, in this case, for example, or a document that's labeled or categorized. In this way, you can give all this information to the network, and the network will train itself and learn from this data set. This is called supervised learning. Usually, as I said, you get some image, you say to the network, this is a person, this is a cat, this is a car, or something like that, and it learns. Once you've done this process, you get a trained model. The trained model can be used to do inference, so you give to the network new input, and it tells you the probability to have a people in a photo or a traffic light or something like that. The first part of this process, the training, it's quite time consuming. It can take hours, days, sometimes week or month. So having all the software optimized for your architecture is really important. On the inference part, usually it's quite fast. You don't need too many time to do inference, but time is crucial. Performance is crucial because you have to give a response to the user as soon as possible. So the Intel Deep Learning SDK cover all the workflow of the deep learning, from the data preparation to the build a model, train the model, do optimization, and do inference. And providing to you all the tool you need to do all this step in an easy way. So the idea is to try to give the ability to more people to try and get started with deep learning, giving a very easy installer that allow you to install more tools in one time. So you get installed so many tools, so many frameworks from TensorFlow, Caffe, and many others in the future. And also all the tools you need to get started. So you have a nice wizard that give you some hint on how to get started. You get Jupyter Network, we'll see later, and many other tools. So the first part is plug and train. As I said, you get an installer that you can use on your PC, Windows, Mac, or Linux. There is no problem. You can install it on a server, on Amazon Web Service, wherever you want. It doesn't matter. So you can just start using it as on a single computer and get started. But also it allows you later to scale out easily. We will see this later. All this is done with a nice web interface or with Jupyter Notebook. As I said, one of the important things is performance in deep learning, because the training part is really time-consuming. And with this toolkit, you get all the framework, the popular framework, optimized for Intel architecture. You get usually 10, 20x better performance than the common open source framework. You also get installed the Intel mathematical kernel library, so you get also this improvement. And also for the inference part, you get so many performance improvement. It's all you also to optimize a model that you already have, but we will see this later. To optimize and for a specific architecture. This is quite important because you can have the better model ever, but if the model can fit your edge device, your phone, your IoT device, it doesn't matter. So it's quite important even to optimize the model for your hardware. You can use this framework to scale out easily. If you start small with just your PC, you get installed all the things you need to scale out on a cluster, so you can deploy it easily on more computer. And under the hood, there is a Kubernetes orchestration server, so it uses Docker container to provide you all the various framework. And this orchestrator just handle all the workload and split it on many nodes. You also got really nice productivity tools. In the training part, if you use the wrong parameter or the wrong data set, you can waste so much time because, as I said, in the training process, you spend hours waiting the network to learn, and while it does this, you don't have any feedback usually. With the Intel Deep Learning SDK, you get also a graphical view of the overall process. so you get live view on how your model will be. And so you can just change the parameter accordingly or stop it and start over without waiting the end of the training. You also get the interactive notebook, so you can, if you don't want to use the wizard because it doesn't expose all the tool you need, you can just start to use the interactive notebook, so code in Python, for example, with TensorFlow or Caffe, as up to you the choice. And you can just start code the live coding and execute the code just in the notebook. I think that if the demo is going to work, I will show you this. You get a model visualization, as I said, a step-by-step wizard. And for the optimization part, if you already have a model, you get also the ability to compress the model, to quantize it, or to make optimization based on your hardware. You can also use this tool to accelerate the deployment. In this way, you will be able to get the model that you have and optimize for the hardware. You get a nice API that allow you to use a model that you build with a tool, with other framework, give you the ability to convert the model in for each framework of your choice, and also to optimize the inference and enable to integrate the your application logic in the inference. So the model optimizers is quite complicated, but toolkit exposes a really nice web interface even to do this kind of task. You can get from the optimizer OpenVUX code that you can integrate in your computer vision program. You get IR model. You can get also accuracy and statistical report. And all this with a really easy a tool that is really easy to use. Also, it allows you to convert the model from format to format. You can use a model that you haven't done with the toolkit. So if you have already a model trained, you can just use the toolkit to optimize it for the Intel architecture. This comes really handy because if you have already a model trained, there is no need to do it to train it again, but you can just optimize it for Intel architecture. The inference engine that the toolkit provides is quite nice because it's offers a unified API that allows you to use your model with just independent from the framework that you are using. So you can use a model that you made with Caffe, with TensorFlow, for example, using a simple load and infer interface. You get also optimization for very large hardware target. So FPGA, for example, you can optimize for it if you have an FPGA to play with. You provide feedback also in the inference part, so you can just try to use your model, see how it performs, and have a look if it's good enough. I think that, yeah, there is even other tool that it's quite far advanced to use, so I don't know if it's meaning to talk about it today. But what's the use case for this toolkit? I think that you can use this toolkit for every field where deep learning is meaningful. So for autonomous cars, as I said, product recognition, gesture recognition, text recognition, for example. Intel, at the last year, IDF show off a headset that's called the Project Alloy. And it's used this toolkit to do hand gesture recognition, because you drive the handset with your gesture, and it will show you in VR your hands. So it's reproduce your hands in VR. And I think I missed a slide. So the training set for this kind of problem is quite easy. So you have a mini picture of hands, a mini picture of not hands, and you train the model with this kind of image. I should have a video to show you. Oops. OK, should start. Start starting, just a second. So, for example, you can see how it's performed with this kind of training. It is recognized, not every time. Sometimes it gets confused with our object, as you can see, like the teddy bear that's taken up. But as you can see, this is quite a simple example, but you can get really good results. Yeah. And that statistically is good enough, even if it's not perfect. Now, I want to show you a demo if everything's going to work. I love the VR demo, but I have more problem that's more meaningful for me, and it's okay. Find where I can swim while swimming near my home. That's quite interesting topic because some years ago I wrote a book about while swimming in Italy. So I have a huge data set to start with this, and I just started to think how I can easily find other places where I can go while swimming. And doing this, I end up with a nice solution that I will show you. I just illustrate to you briefly the idea. I just took some map tiles from OpenStreetMap, where I know that I can go to while swimming. Then I trained a network with this image, and given the network other image that I'm sure that I cannot swim there, like city or place where there is no water, absolutely. I got a trained model that can infer if on a new tile map that I will show you to it, if I can go swim or not swim. So I can just automate the process of finding new while swimming places. That I think it's quite awesome. So I have to switch the computer. Just a second. Oops. Can you help me?
Sorry, everyone, to interrupt. I'd just like to use this chance to tell you to vote the session before you leave the room. And today, only today, you can go to the Cisco lab and you can get some pretty cool gadgets and win an invitation to the Codemotion dinner. Thank you.
It's quite. OK, I think that we can just keep this color. OK, it's not perfect, but I think that you can just got it. So this is the Intel Deep Learning SDK tool. This is the web interface, as you can see. You can use it in any browser. And you got just a dashboard where you can just get started. So the first step is to prepare your data set. I've done my homework. So it's quite small, but you can get. The input that the SDK wants, it's simply a directory structure where you get some folder that it's your categorization. So I have the swims that it's just a folder with map tile of place where you can swim. As you can see, I can show you just. So it's like you can see that the image has something in common. There is also water bodies, so it's like one of the key that the network can use to distinguish it. And then I have a folder with random place where you usually can't swim, so it's just a road and some random places, house, and so on. So you can just zip your folder here And with the tool, you can just upload it from here. OK. You can upload it. So you get your data. And you can just create your data set. So you give the data set a name, Codemotion. You can just choose the folder that you already upload. And what's interesting that the toolkit allows you to do some processing on the image that you are uploading, for example. You can, at the moment, do image processing and text processing with the toolkit. And you can do some process on the data that you give to the tool. So you can just choose, for example, how many images they leave for the validation and for testing purpose. You can also balancing the data that you are giving to the tool, or you can just go through the wizard and click next. You can also do some of the transformation. Usually when you prepare a data set, the data need to be coherent and normalized. So for example, one of the common tasks that you need to do is resize the image. So you can do just from the tool. You can also choose how to resize. So if you want to squash, crop, fill, or something like that. But you can just go over, choose the database backend. If you are getting started, doesn't matter, and you can choose the format of the image that you're using. So you just click on Create Dataset, and you get, we have some visualization problem, but you get some information on how, just a second. You get some statistical data, so how many images you used for one category, for another category, and so on. Then you can just go to the Creation, to the Model tab, and create your model. You give a name also here. You choose a data set. You click Next. And from here, you can choose the topology of the network that you want to use. This is not the latest version of the toolkit. Actually, there is more topology than this. And as you can see, you get some of the famous and known topology that it's known to be good for this kind of problem. So you get the LeNet topology it's usually used for text recognition, for example. You get the AlexaNet, the GoogleNet, that is quite good for image processing, for example. So yeah, we are choosing this one. You can also do some fine-tuning on the topology. So you can just tell the tool how it should be aggressive for some parameter. But as I said, it's a wizard, so you can just skip and go on. And even from here, you can do some post-processing. So you can crop the image. You can do the subtraction mean on image or a pixel. You can mirror the image to get more data from your data set. And you can choose some of the parameters that you need to do the processing. So just to be fast, I will choose something easy. And you can go on. So this process can take time. I think it's going to take like 20 minutes. But as you can see, you get live data on how the training process is going to be. So from here, you can just see if your trained model will be good or not. You can avoid to waste time waiting the complete of the process and just stop it if it's not good, or leave it going if it's good enough. Yeah, I think it's going to take a lot of time, so I should have something already done. As you can see, you can play the graph and see how it works. You get some statics on the model. OK, this model is not quite good, but you get how many hits and miss you have on your data set. you can have a look, an overlook on your data set, so you can get statistical data on the train or how the train goes. And also, you can do easy testing from here, from the web interface. So you can just select an image to test. Somewhere. You can just upload your test image, and hopefully you get the results. OK, now the computer is doing some hard work, doing the other model now. But from here, you get just the ability to test your trained model. So you upload an image, and it will tell you if it fits one of the category that you have on your model. And this is quite handy, because you don't need to code to just give a try to your model. And you can just do it from the web interface. You can also have some details on your model, on how you have done it, on the optimization that you have done. OK. We don't have meaningful results, actually. OK, demo effect. Sorry about that. So I think that it's a really nice tool to get started, because it allows you to don't waste time on things that it's not important. When you start to play with deep learning, you can just start and try it, try to build your model, train your model, and see how it's works. But if you need something more advanced, the SDK provides what's called the Jupyter Notebook. I don't know if many of you know this tool, but it's quite nice. For example, so the Jupyter Notebook, it's like a web document where you can have part of documentation, part of code, and you can run the code just inside this document. So you can just highlight the part of the code that you want to run, press run, and it will run it. So it's a nice way to play and just test things out. So you can just train a model, as you've seen before. And for example, this is a really nice cat. And you can just try your classification and your model from this network. You can just code from here, so you can change parameter, you can change the image source, you can write a small bit of code to, all right, thank you. You can write a small bit of code to try out not only one image, as I have done before, but with a set of images, for example. So if you need anything that is a little bit more complicated than what you can do with the toolkit, you can just do it from here. Unfortunately, this version of the SDK that's installed on this machine is quite old, and it lacks the optimization part. So I can show you. But you get, in the same way, you get just choose your model. You give it a name, and you got the ability to choose some options to optimize your model for your target. So you can, as I said before, compress it, quantize it, optimize it for a specific architecture. So for example, if you are targeting an IoT device, you can just compress it and have it ready for your edge device. Or if you just need to deploy it on an FPGA, you can just optimize for it. So I want to show you another thing, but I don't know if the process is going on. Yeah. No, OK, it's not ready still. But while you are doing the train, you can get many statics on your model, and it's quite nice. But it's not ready still. So just come back. OK, I need to switch back to the computer. So I think that I give you a small overview of what the Intel Deep Learning SDK is. And exactly, it's in heavily development because we are adding so many other frameworks. For example, we're adding new optimization option, and so many other nice things are going to come. So please go to the website, download it, and give feedback, because it's quite important at this stage of the project. I hope that you have you want to try it and just get started with the deep learning and have fun. Thank you. If you have any question, yeah, just a second. I need to test you.
Yeah, two questions. What is the licensing for the product? And the other one is, what is actually the hardware platforms that it supports for the training?
OK, you can use any hardware that you already have on Intel architecture, I mean. And the license of the framework that you are using is still the same. So if you're TensorFlow or Caffe, it's everything open source. I think these proprietary licenses, I don't know which kind of proprietary licenses on the interkernel library, for example, mathematical kernel library, for example, or from other part of the toolkit that is not open source. The web interface is not open source, actually. And I don't know if it's going to be open sourced. But you can just start using it on every PC with Windows, Mac, or Linux. It's the same. I think that you can use also on Amazon Web Service, for example. So I think that it doesn't check what the architecture actually you are running on it. But obviously, if you run it on Intel architecture, you get the performance boost. Else you are not getting the performance boost, and maybe even some error, maybe.
Thanks.
Thank you.
Does this SDK require some pre-installed stuff for Python, for example, all the MKR stuff?
No, it should start install everything that it needs. Underlaying it's using Docker, so it doesn't mess up your system if you care about that. And so it's everything in a container, and you can just run it, and it's running it on the container.
OK, thank you.
No one else? So thank you.